So if you can't taste low concentrations of bitter substances like phenylthiourea, that's a autosomal recessive trait, okay? So people can be tasters or non-tasters, and 64% of people dislike spring greens because they taste really bitter. So what is the frequency of the taster allele? So for these types of questions, I like to just write everything we know. So I start off with writing the Hardy-Weinberg equation. So we have p squared plus 2pq plus q squared equals 1. So then what else do we know? Well, they gave us the information that when we can't taste the low concentrations, that's an autosomal recessive trait. So we can say that capital T means that we can taste it, and the recessive trait means that we cannot taste it, right? So no taste. So people can be tasters or non-tasters. So what does this information tell us? It tells us that we need 2 recessive alleles to not taste these bitter things. And it only takes 1 dominant allele to be able to taste these bitter substances. So the next part is 64% of people dislike spring greens because they taste really bitter. Okay? So what does that tell us? It means that 64% can taste these bitter things. So that means that they have a dominant allele. So which one out of all 3 of these has dominant alleles, right? So this one has dominant alleles because this is homozygous dominant. This is heterozygous. So this is composed of 1 big T and 1 little t, and this is 2 little t's, right? So that means that both of these, they can taste. They're tasters, and so they can both taste the bitter substance in spring greens. So that means that this entire part, right, p squared plus 2pq is equal to 64%. On top of that, so that by itself can't actually give us any information because there's still too many variables to figure out what we need. So what instead we can do is look at the other part. So now, so since it has to add up to 100%, we know the other part has to be 36%. So now this is useful because there's just one variable. So remember to always keep in mind the difference between genotype and allele frequency, right? So this is giving us the genotype frequency for the recessive allele. So that means 2 recessive alleles. So that's 36% or 0.36, right? And always keep in mind what you're actually asking to find, right? So we want to find the frequency of the taster allele, not a genotype, but an allele. So for that, so this is what we want, the p allele. And so right now we have q squared. So let's find q, right? So the square root of 0.36 is 0.6, right? So that's where we got right here, 0.6. And so now since we have the allele frequency, right, remember this is genotype frequency, we have the allele frequency of 0.6, we can plug it into p plus q equals 1, p plus 0.6 equals 1, and then finally we can solve for p, which is 0.4, and that's 40%. And so we did answer the question because it asked for what is the frequency of the taster allele, and this is the p allele, which is going to be the dominant allele, and thus the taster allele. So I hope that helped, and thanks for watching.